Bismillahirrahmanirrahim. Dear students, chapter number 19, this lecture number 56, and the last time we completed the aldol condensations. Now we start the haloform reactions according to your reduced syllabus. Base catalyzed hydrogen cyanide we completed, condensation reactions we completed. Now haloform acid catalyzed 2,4-D and pH. 2,4-D and pH. So these were the base catalyzed nucleophilic addition reaction. Now acid catalyzed nucleophilic addition reactions. So acid catalyzed now. Acid catalyzed nucleophilic addition reaction. Acid catalyzed nucleophilic addition reaction, this is a new topic. The addition is initiated by the proton because we are talking about acid catalyzed, liberated from the acid. So acid gives proton, which combines with the carbonyl group, It increases the electrophilic character of the carbonyl carbon. The electrophilic character of the carbonyl carbon is going to be increased, and the attack of weaker nucleophile on the electrophilic carbon becomes easy. So this is the general mechanism. General mechanism of acid catalyzed nucleophilic addition reactions. So this is the carbonyl group, maybe aldehyde, maybe ketone. This is the nucleophile oxygen. This is the electrophile carbon. And this is the proton which is liberated from the acid. Proton liberated from the acid. This is the carbonyl group. And this nucleophile is going to be attached to the electrophile. This is the nucleophile oxygen, and this is the electrophile hydrogen proton liberated from the acid. So for the time being, you will get this. Now the valency of the oxygen is going to be exceed 2 plus 1, 3. So positive charge is created here. Then he said nucleophile is going to be attacked. Nucleophile is going to be attacked to the carbon, electrophile. Nucleophile is going to be attacked to the carbon. The pi bond of the carbon oxygen bond is going to be broken down. These are the mechanism we write reversible. Mostly we write mechanism reactions in the reversible form. So this is a nucleophile. So you will get the same product. Already I told you in the previous lectures that either the base catalyzed nucleophilic addition reactions or acid catalyzed nucleophilic addition reactions, the product will be same. The last product you will get same. If you go back and see the product, you will get same this one. So this is the general mechanism of acid catalyzed. This is the acid catalyzed hydrogen ion generated from the acid. This is the carbonyl group, partial negative charge, partial positive charge. And this nucleophile oxygen going to be attacked with the hydrogen proton from the acid, and you will get the intermediate product this, and then nucleophile is going to be attached to the carbon, and pi bond of the carbon oxygen is going to be broken down, and you will get the product. Dear students, this is the general mechanism, and he says for the chemical reaction, haloform acid catalyzed. Haloform acid catalyzed 2,4-D and pH. So this is okay. Let me finish, then I will tell you. Now, if you see the page number 255. 255. Addition of ammonia derivatives with aldehydes. Addition of ammonia derivative with aldehydes. So aldehydes and ketones react with ammonia derivatives. So this is the addition of ammonia derivatives with carbonyl group, means maybe aldehyde and maybe ketone. Aldehydes and ketone react with the ammonia derivative to give a group. This is the group, and this is the amine group. This I will tell about the group. To form compounds containing this compound you will form. This CNG. This compound you will get in the last, C and G. G is the group, this is amine, and the carbon, alkyl group. And removal of small molecule is called water. So these addition of ammonia derivatives with aldehydes are called condensation reaction or addition elimination reactions. These reactions are called condensation reactions or addition elimination reactions. Condensation reactions or addition elimination reactions because water is lost after the addition occur. When the addition takes place, there is a removal of one water molecule. That's why we call condensation means removal of water, addition and elimination reactions, or we can say this one. So the general mechanism for the ammonia of addition of ammonia derivatives, I am going to write here general mechanism for this general reaction. General reaction, this is the carbonyl group, aldehyde may be ketone. This is the carbonyl group, partial positive and partial negative, and this is the amine group. there is a group attached. I will explain what are these group attached. But main is the NH2, main is the amine, this is going to be participate. We are talking about acid catalyzed nucleophilic addition reaction. So this hydrogen ion proton acts as an catalyst. So what happens? This is the lone electron and this is going to be nucleophile and attach the electrophile of the carbon. So one of the hydrogen from amine, one of the hydrogen attached with oxygen to make a OH group. So this is the carbon and there is the oxygen. Hydrogen is added to make a OH group. Double bond is removed and this bond is going to be down. There is the one hydrogen more with the ammonia and H. So what happens? This is the group. This is an intermediate product. This is the addition takes place. Addition and elimination or condensation. First addition, this group is going to be added with the carbonyl group. Then there is a condensation or elimination, removal of the one water molecule is going to be removed from this one. So you will get the CNG. This carbon bond, maybe the two hydrogens, maybe the two alkyl groups, maybe the one alkyl, maybe the one hydrogen. Double bonds created, and this is the group plus one water. You will get the same. Look, this product you will get 100% same. This is the general mechanism for the ammonia derivatives. Acid catalyzed nucleophilic addition reactions. I explained the general mechanism for this, and you will get this product, CNG products, and it is going to be formed from the carbonyl group. This is the carbonyl group, maybe aldehyde, maybe ketone, and this is the amine derivative with the group here, proton, which is acid catalyzed. Nitrogen has a lone pair, which is a nucleophile. Carbon is electrophile. Attack here, one hydrogen is going to be attacked. You will get the addition product is intermediate and the removal of water to get this product. So this is the addition of ammonia derivatives. Now here is acid catalyzed 2,4-D-NPH. So dear students, there are many groups. There are many groups. I am going to write groups because only the chemical reaction is of D and pH. G for group, and they are attached with the amine group. There the bond. So these groups are, I am going to write maybe OH. Maybe you can put OH here, hydroxylamine. This OH is a group. Maybe you put here phenyl hydrazine C6H5NH. Maybe you put this one with NH2, then it is called phenyl hydrazine. If you I'm going to write like this one. This NH2 is a must, and this group, this is a group OH. This is called amine hydroxyl, and then there is a phenyl hydrazine. This is NH2, this is the must. This is the NH2 must, and G is a group. This is called group. Here group. Here this is the group, and NH2 is must. And there are many like this one. then only hydrazine, maybe like this one, and another NH2 group. So this is the same NH2, this one, and this NH2 is the group 1. So there are many. So there is a which is given in the book DNPH, which is called 2,4-dinitrophenyl-hydrazine. 2,4-dinitrophenyl-hydrazine, which is like this one. Benzene, and there is a hydrazine. This is hydrazine, and then carbon number 1, carbon number 2. There is a 2,4 nitro group, 3, 4, 5, 6, like this one. 2 nitro, 4 nitro, 2, 4 dinitro phenyl hydrazine. 2,4-DNPH. If you see the last topic, 2,4-DNPH, 2,4-dinitrophenyl hydrazine. So students, this is the amine NH2 group, which is going to participate in the chemical reactions. So dear students, this is the group. This is the group. Second position nitro, and fourth position also nitro. So this is the group. This whole is group, and when you attach with the amine like this one, so this will participate. This is going to be participate. That's why we call 2,4-DNPH. So now I am going to complete with the DNPH with aldehydes and with the ketones. I am going to write the chemical reaction for this. This is very important, and they may come base catalyzed nucleophilic reactions and acid catalyzed nucleophilic addition reactions, and especially we are discussing here addition of ammonia derivative. There is some confusion in the topic. I am not going to discuss this, but this is the original one topic. So addition of ammonia derivatives with carbonyl compounds, maybe aldehyde and ketone, and specific is given in your book. This group only given. You can use this, you can use this, you can use this, you can use the hydrazine any, but in the specific reduced syllabus, this is given. Same. This is the NH2. See the mechanism. NH2. This is the NH2 around it. This is the group whole. You can use this one. I am going to write here now to make the product. So, dear students, you can use. I am talking about 2,4-DNPH. So this is the. I told you can use acetaldehyde. You can use the ketone. Same. This is the amine. This is the amine derivative. I told you must participate and then there is a group. I am writing this one. So this is the carbon 1, carbon 2. So this is the carbon number 2. There is the nitro group, and there is the 4. This is the nitro. This is called 2,4-dinitrophenyl. 2,4-dinitrophenyl hydrazine 2,4-D-NPH. In the presence of acid catalyst. So dear students, only you have to participate this one. So if I am going to write directly, this is the condensation, addition, condensation. So water is going to be removed and you will get the CNG. So this is the acetaldehyde. Double covalent bond is established. 2 hydrogen atoms are removed. You done in the previous, I wrote in the previous journal. This is the nitrogen now. Now write the group as it is. Write the group as it is. 2, 4. With removal of water. This is your answer. So this compound is called acetaldehyde 2,4-D-NPH because you use acetaldehyde. Acetaldehyde 2,4-D-NPH. Acetaldehyde 2,4-dinitrophenyl hydrazone. Now this is the 2,4-dinitrophenyl hydrazine, and this become 2,4-dinitrophenyl hydrazone. Now it is called hydrazone, and this is the hydrazine. This is the hydrazine. Dear student, this is the chemical reaction which is given in your book in the reduced syllabus. Addition of ammonia derivatives with 2,4-D-NPH with the acetaldehyde. You can use the acetone also. Okay, I am writing again. I am writing again using acetone because there will be a revision. Very important. This is the acetone, and this is the ammonia, amine, and there is a group. This is a group stored from here. 2. You can start from here. Sometimes 2 is given, 4 is given. It making no difference. All sides are equal. This is a 2,4-diphenyl hydrazine. In presence of acid catalyst, acetone, now double bond is created, all same. You can write here 1, 2, 1, 2, it makes no problem. Like this. So this is called 2,4-dinitrophenyl hydrazone. Now we use acetone, that's why now its name is acetone 2,4 DNPH, hydrazone. So this is the chemical reaction. You must remember, very important. Only this is given in the acid catalyzed, but there are also other same. Because of the group is same, no change in the group, only the last amine is going to be participate. Whatever in the group, just add. If there is a hydroxyl group, only OH add. That's why. So there's no matter. Only the participation is going to be amine to make a water. Addition and condensation reactions taking place. So dear student, this is called acid catalyzed 2,4-DNPH. Before it is called haloform. The haloform reaction is also given. Before you can see the page number 223. So I am going to read saying, because this is a minor practical for you also. So maybe written here haloform 19.51. 19.51. 19.61. 19.644. Base catalyzed HCN, condensation will be done, haloform now, okay. Now in the haloform reactions, if you see the page number 223, this is the minor practical for you also. There is identification of the ketone, alcohol also. But there is one very important thing written in the very first line. Only these compounds can react. Only aldehyde, acetaldehyde. Only the aldehyde, which is good. I am talking about the haloform reaction. This is very important. Please copy it. Write down very well. Remember it. See the book also. I am going to omit this, then haloform. He said only, aldehyde is only, acetaldehyde. Acetaldehyde is only, and small methyl ketone. When we say small methyl ketone, means one side must be attached CH3. Otherwise, this side may be many in alkyl group, but one side must be attached CH3. So we call small methyl ketones only the acetaldehyde from the aldehyde group, and small methyl ketone react with halogens. Also there also in the primary alcohols only ethanol. Primary alcohols only ethanol, and the secondary alcohols containing methyl group this one. like this. So this is the secondary alcohol. So this carbon, this is the alcohol which has an ability to attach here. So this must attach a CH3. Here may be 2, 3, 4 carbon atoms may be there. So they will give the haloform reactions. So I will explain one from here. So dear students, I am going to write one chemical reaction from us. First I will write for aldehyde. Only aldehyde. This is acetaldehyde only, not of other. So haloform, we use bromine, chlorine also, but here especially I use iodine. That's why these reactions are called iodoform. Iodoform CHI3. This is called iodoform. Haloform CHX3. This is called a haloform. So we use this we prepare iodoform, yellow crystalline solid. So this is the acetaldehyde. 3 moles of iodine plus you have to put the base. Sodium carbonate, you can use also sodium carbonate, alkaline solution base. So you will get precipitate. This is called iodoform. Yellow precipitate. Iodoform, this is iodoform. So plus you will get the formic acid, sodium formate, salt, and plus 3 moles of sodium iodide and 3 moles of water. But this is the important that iodoform can use. If you use other aldehyde, if you use the formaldehyde, if you use the propylaldehyde, you will not get the yellow precipitate of the triiodomethane. Only this formaldehyde, acetaldehyde can give. You can differentiate acetaldehyde from other aldehydes. Now acetone. Small methyl ketone. One side must contain CH3. This acetone, iodine. I put iodine in a solid, dark, brown color, blackish, very smelly, solid. So sodium hydroxide. Then you will get iodoform. This is the product. Yellow precipitate you will get in this case also. Because 1 carbon more you will get sodium acetate and 3 moles of sodium iodide plus 3 moles of water. So this is your chief product. That's called iodoform. Sodium acetate, sodium iodide, water, iodoform, yellow precipitate. Yellow precipitate is going to be formed by using only acetone or small methyl ketone and acetaldehyde. Then you have ethanol also. Yes, I told you ethanol to give. This is ethanol. Primary alcohol, only ethanol. This ethanol plus iodine plus sodium hydroxide. And you will get iodoform. This iodoform plus sodium formate and sodium iodide and 5 water molecules. So this is again iodide. Iodoform is going to be formed with the alcohol. So this is the number 1, this is number 2, and this is number 3. And I am going to write for the secondary alcohols. I told you. This is the alcohol attached with a carbon, and there must be alkyl group, methyl group. Secondary carbon on one side must be attached CH3 like this one. Ketone group on one side must be attached CH3. Aldehyde on one side must be attached CH3, not other. No hydrogen, no more alkyl, CH3 common here. So this is a secondary alcohol. You can use for this 4 moles of iodine, 6 moles of sodium hydroxide. The product is iodoform. Yes, iodoform is going to form yellow precipitate. You will get acetate group plus sodium iodide, 5 moles of sodium iodide and 5 moles of water. So these are iodoform. Iodoform. This is a minor experiment also for you. Take a round bottom flask and you have a big beaker, put water and put on the Bunsen burner, and you have a round bottom flask, put the acetone, alcohol, acetaldehyde, secondary alcohol, water maybe you have to put it inside, and temperature must not increase more than 55 or 56, not more than 60 degrees centigrade. Maintain it by a thermometer. When you are going to heat, you must stir. Then you have to put the base, sodium carbonate, you can add sodium hydroxide, dilute solution, you can put it, small quantity. Then pinch by pinch, small quantity of the iodine by using a spatula. You have to add in the round bottom flask by shaking well. So it will be dissolved slowly and gradually and giving the yellow precipitate. So when it is going to form, take out, burner off, cool it, filter it. So this yellow precipitate is called iodoform. And again I will tell you that iodoform is only formed in the acetaldehyde, no other aldehyde. No formaldehyde, no propanol, no butanol, because CH3 in ketone, one side must contain CH3. Here CH3 you can put any number of carbon, but one side must be. Only the primary alcohol, ethanol will give. In secondary alcohol, again there is a condition that this is a secondary carbon. The secondary carbon with the OH must contain CH3. The CH3 must contain either this side or this side. There's no problem. So they will give the iodoform. This is a triiodomethane. Triiodomethane, iodoform, yellow precipitate will form. So these chemical reactions are called haloform reactions. So it is given, that's why I told you about this one. So students, the last topic is oxidation reactions. Oxidation reactions in the yes 19.64 oxidation reactions. In the next time, inshallah, next lecture we complete this chapter and then we will start chapter number 20. So very important these reactions are, so you have to see very well.